Right, well I've tipped the base over so that I can get stuff underneath it. So we can see the two hollow bases with the right hand part of the right hand base being occupied by the electrics. And what I want to do first is to get this coolant tray and pump off, and as the electric cable for that disappears behind into the electric box behind all the gubbins, I'm going to have to disconnect it at the motor end. Oh, that came off easy enough with a rubber joint washer. Well, I think there are just 3 bolts holding this. I don't particularly want this thing falling on my toes. I never know what the original colour was. Is this the same colour as that, except that this has changed? Or this has faded because it's in the dark? I don't know. Should settle it. Right, so that's the coolant reservoir, and there's the pump down there. We'll take that to pieces and see what's what. And in the motor there's a nice, hopefully, wiring diagram. The usual star delta options. So I just cleaned the top and it says delta 220 volts, Y 440 volts. And 0.15 amps, and it was in the Y configuration, which is what it should be for 440 volts 3-phase, so that's fine. This is held in by 2 hex, 2 set screws, and they're not particularly easy to access at this angle. Could be here for some time. This is only the first one. Right, so short hex screw, set screw. Right, well I've got both screws out, so hopefully this will now just lift out. What it would do, were it not for this extremely inflexible cable, pipe. So now it should come out. Right. I don't know if this motor is working, and I listened to it when I ran the lathe before I bought it, and I couldn't actually hear it. I wasn't sure whether it was working or not. The coolant that was actually in the pump appears to be green. Don't know what that signifies. It smells quite sort of healthy, unlike coolant trays that I've seen other people clearing out. This one does not smell foul. I'm not quite sure how this comes off, because these three things don't look like pop rivets. I presume this comes off. Yes. There's just a little impeller in there. Yeah, right. Just takes the impeller off. Odd thing about this impeller is it's absolutely flat. The blades aren't angled at all. So this is plastic. So I'm pretty sure that I guess I'm going to have to undo these three screws again. Well, maybe it does. Yeah, right, so there's the motor, which just looks in good nick. And there's a bearing there, which is an enclosed bearing, which is perfectly okay. I wonder if there's a shaft seal on the other. Yes, and these things are pop rivets, so I can't get that off. Just wonder if there's a shaft seal. Yes, I think there's a shaft seal there. Doesn't look very round. Well, the shaft is a bit manky. I think the bearing sits there, and this bit here is where the seal runs. It's a little bit rough. Just wondering why I can't take the rest of this out. I think the shaft is pressed into the top bearing. Don't really need to take it out, I suppose. So this impeller is a loose fit in there. I was just wondering, what is the point of this hole here? Because it's supposed to be sucking oil upwards from there and expelling it there, isn't it? I mean, it's this way up. Perhaps if you block the outflow, then the pump expels upwards through this slot as a kind of bypass. I don't know. Well, actually I think I will drill these three prop rivets out, because I think I can see some swarf down there, and that will also enable me to see the condition of the shaft seal. Right. Well, maybe it wasn't exactly swarf. Gunge of some kind. So, is that a That's aluminium. What's this? Because it's not so easy to get those out, is it? They must be pressed in from that side. And if you want to replace them, what do? The only bit I can beat on from this side is the inner race, which is not what I normally want to do. There's actually a kind of thin strip of crinkly steel, perhaps, between the outside of the outer race and the ID of this. So it's not exactly pressed in. I've turned this piece of aluminium to be 0.8 millimeters larger in diameter than this, the shaft that normally goes through here. So I'm thinking that I could just get that like that, and now that's pressing into there. And I'm wondering if I give this an appropriate bash, whether it would take that bearing out. Don't think it's moved it at all. Well, rather than bashing it, let's, there's always something in my way in this place. Let's let me just see if I can just. Yes, I can. That has brought it out. Right. Well, I had to shorten this piece of aluminium because the vise won't open far enough. And that's cut off at an angle. It's got a bow on it. I'll just put it in the lathe and make it flat. Right, I've just turned that flat. I faced it off. So hopefully now, if I get this in the middle, it will come out cleanly. Well, I expect the bearing is okay anyway, but I had kind of hoped that by forcing this slightly oversized thing through this oil seal, it would spring back to its natural size, but that is not the case, because I can see now that if I put this on here, the oil seal is loose. So I've definitely got to replace that oil seal anyway. Let us hope that I can find one. These windings are in a Y configuration, so we can just measure the resistance of each half. That's 335, 323, 320. So that seems to be okay. So we can measure the insulation resistance between the windings and the case. And it is enormous. It's very much greater than 200 megohms at 500 volts. So that's good. I'm thinking that the shaft, where the bearing goes here, but where the shaft seal goes, it's slightly worn, and slightly rusty. I think I'd just like to kind of clean that up a little bit before putting a new seal on. There is a ledge there. Just comparing the old and the new seals, I think that the old seal is it binds on the shaft 4.2 millimeters from this face, whereas this one is more like 6 millimeters. So that means that if I put the new seal on, it will be a bit further in, not actually on this groove. So I think that's going to be okay. So I put the seal in there, and I'm going to reuse the bearing because it seems to be perfectly okay. There's a space between the two which I'm going to put grease into, just so that the shaft seal has something to grease it. The motor is always facing downwards, so that seems sensible. The bearing, and I think I can just tap it in. Now, because I've got it all skew with that's still not right. I'll put that in the vise. Right, it's seated in there now. Right, I'm going to put this back on, and it goes only one way because the holes are not exactly symmetrical. And this could be a problem because maybe I can't get. Come on. You're supposed to break. Oh, you have broken off. Okay. What's the point of having these handles so far apart that you can't bloody well get on them? Typical Stanley. Shit. Don't have any brains, these people who design things like this, do they? They just don't have any brains. Sit. Now, where's the other one gone? It was originally installed like that, with the pipe coming up there and then being bent under this and coming up that way. Seems to me that it would be more satisfactory if one installed it like that, the pipe coming up this way. So I think I'm going to install it like that, which means that if I put this motor around that way as it should be, let's see if I can do that. That's the only way it will go, where everything lines up. So it's got to be like that. Alright, I'll put it like that. Right, so that goes on there. I've made a right mess of this really. I was hoping to be able to nickel plate this, but I did not succeed in doing so. I don't know what's there. Could it be chromium plating? Anyway, it's obviously on its way out there. Well, I'm just trying to remove the rust electrolytically using a current of 5 amps, which is the maximum that power supply can produce, and it's producing a nice revolting scum there. This wire gets hot. Not sure if it's just the 5 amps. It's doing well. Yeah, well, that's just this is actually current limited, so it should be. Yeah. Just turn the electricity off for a moment. See if I can get this to lie. It's fine. Well, would you believe it? I keep emptying this jug, refreshing the water, and it keeps coming up with this incredible stuff. Where the hell is that coming from? This time I didn't actually put any washing soda in there. This is just water and electrolysis that's doing this, and it was only at a couple of amps. So if I turn this off and extract this, I'm beginning to think that this thing is generating its own rust. I also completely cleaned the sacrificial anode, so that there was no rust on that. I think it's generating its own rust in real time. Well, you know, it's not clean. I think what I'll do is put it in evaporust overnight, which I've done before. It still doesn't, but at least it'll stop it rusting anymore. I tried to restore this filter, which I can't take off because these caps are sitting on very thin plastic stalks, which I dare not pull off for fear of breaking the thing. So I've soldered up this little hole that was there, the one hole in the thing. And I have tried to nickel plate this after stripping the rusty chromium off it. It's not completely successful because it's just very dirty, difficult to get clean, particularly when I can't take it off here. But anyway, it's better than it was when I started. I was just cleaning up this coolant tray. And the interesting thing about it is that the top coat appears to have been applied without any undercoat or primer. It does seem to be undercoat or primer on the exterior of it, so maybe it was only the inside that they didn't bother to paint properly. Well, just looking at the inside of this, appear to be a few pinhole leaks right through the bottom of this coolant tray, one in the corner there. So it's 3. I've had this flux for about 60 years. Doubtless it's full of carcinogenic things, but I know nothing about that, so that's good, isn't it? I've had this soldering iron for about 50 years too, or maybe 60 years. It's unusual in those so far as it has a carbon element here, and when you press the handle forward, it just it pushes this forward and creates a carbon arc just behind the tip, which heats up quite a lot, and it's 150 watts, so you know that's quite good. The only problem is you have to replace this carbon when it wears out. So it heats up quite quickly. It's cold at the moment, but then 1 elephant, 2 elephants, 3 elephants, 4 elephants, 5 elephants, 6 elephants, 7 elephants. In 7 elephants it's hot, which is good. Well, I'm sure this isn't the best way of patching up these holes. A welder would be better, but I haven't got a welder, so we're just going to have to try and solder them. Of course the iron can't come anywhere near heating up this whole thing, but it might be able to just manage to heat it up locally enough to seal us. And then if I paint it with epoxy paint on the other side, do you think that might do? Ouch. Of course that is hot, as one might expect. Well, that solder did actually come through to the other side, which is a help. Well, that doesn't look too bad. It's definitely filled up the holes. I think what I might do is to line the areas underneath on the inside with some epoxy resin compound. Right, this is the coolant tray. I've cleaned it out and painted it with 2-pack epoxy primer, but before doing that I put some epoxy filler of a kind that I have for the robot boat, just in the areas where there were holes going through, just as belt and braces. I've soldered them from the other side and put the epoxy filler there, so I don't think they're going to leak. It's supposed to be the khaki colour of the base, although it was painted in situ on top of this light coloured undercoat. But I've painted it Harrison beige, which is the colour of the upper part of the lathe, basically because that's the colour that I've got, and it doesn't really matter, does it? Except that I've got to put one more coat on the parts of this. So the motor with its pickup goes, the pump motor this is, goes like that, and I thought it was rather silly having the intake so close to the bottom of the tank where it's going to pick up the maximum amount of swarf, etc. So I think what I will do, since there's plenty of sort of air room above this, is make a a ring just so that it mounts a little bit higher like that. Anyway, basically the coolant system is ready for reinstallation now.